Okay, good morning, dears. Can you see the slide?
Yes, we can.
Do you remember till where we did? I did conjugate acid, conjugate base and all that, right? These all finished, right?
Yeah.
This one pH, pH. We were doing pH, pH and all that. Strong acids and strong bases and all that I explained, right? These all slides I explained.
Yes.
This one I explained. This one I explained.
Yes, doctor.
Yeah. Who is that? Sayed came back, Sayed?
Yes.
After 2 weeks? Okay. Up to this slide, I think we did. I mean, this slide we did, right? Now we have to do this slide onwards, right? Correct now?
Yes.
Okay, so now calculate the pH and pH of the following aqueous solutions, and the given things are. This is, do you remember I told you to memorize the strong acids and strong bases, okay? Strong acids and strong bases is one of the methods, and then weak acids and weak bases, another method, okay? So here, HNO3 strong acid or weak acid, tell me?
Strong acid.
Strong acid. So strong acid means it will ionize completely. Okay, it can ionize completely. So you have to write to find pH and pH. You need the concentration of H plus. Okay, so A part of the question, I'm going to write the equation. HNO3 is a strong acid. In aqueous solution, it will ionize completely. I just write one side arrow. Why am I writing just one side arrow? Why not both sides?
Because it's strong.
Yes, because this is strong acid. Who is telling the answer, Sarah?
Yes, doctor.
Okay, yes. Okay, aqueous. Now, what's the concentration? 0.125 molar. What about the concentration of H plus? Also 0.125 molar because it's strong acid. It will ionize completely. Okay. Okay. So the concentration of H plus is equal to 0.125 molar. Now, how do you find pH? Minus log of concentration of H plus, right? That is minus log of concentration of 0.125. Can you tell me the answer, please?
0.903.
0.903. So we have to find pH also. So how do you find pH? 14 minus 0.903. There is no place to write the answer, so I will leave it like that. Did you understand?
Yes, doctor.
Okay,
Yes.
so we do B part of the question. You can help me, please. Come on. Come on.
It's a strong acid, ionize completely.
Yes. HCl for aqueous being a strong acid, it ionizes completely.
Plus.
Yes, this one's turquoise is 0.025 molar. This also is 0.025 molar. Here also 0.025 molar. Now pH plus concentration is how much? 0.025. Now pH is equal to minus log of 0.025. What's the answer, please?
1.6.
Only 1.6. After that, no number?
0.2.
Okay. So pH is equal to 14 minus 1.602. Okay, so now see part of the question. Tell me.
It's a strong base, so the same concept.
C is a strong base. Yes, it's from group 2. Sorry, group 1. It's a strong base. So what equation I should write? NaOH aqueous. Can give one side arrow Na plus aqueous plus OH minus aqueous. Okay, so concentration is 0.025 molar. This is 0.025 molar. This is
0.025.
Yes. Now what's the next step? Tell me.
Concentration of OH.
Yes, here H plus we don't have. Concentration of OH minus is equal to 0.025. So I can find PO is minus log of Turkish of 0.025 molar. So now what's the value?
1.602.
Yeah, same thing, right? So pH is equal to 14 minus 1.602. You understand? So here first you found pH, then hello, first pH, then pH, right?
Yes.
Yes.
Now next one, tell me please.
BaOH2 is a strong base.
Yes, BaOH twice is a strong base. Okay, how do I write the question? Tell me.
A plus
2Ba
H.
Yeah,
plus
Ba2
OH
plus charge 2 plus how many OH minus are there?
2 OH.
2 OH minus. Correct? There are 2 OH minus. So the answer here for 0.125 molar. This also 0.125 molar. What about the concentration of OH minus?
Twice.
Yes, it's twice.
0.125
Times 0.0125. That is equal to 0.250. Correct?
Yes.
Correct?
Yes, doctor.
So next step is OH minus concentration is 0.250. Now pH is equal to minus log of 0.25, and the answer will be, what's the answer?
0.602.
0.602, and then come on. Yeah.
pH will equal to 40
pH
minus
is equal to, yeah,
40 minus 0.6.
40 minus
0.60. Okay. Yeah. I
Yes.
hope everyone understood. Now look at this question. 0.8 gram of BaOH twice is dissolved in H2O to make 100 ml of the solution. Find the pH of the solution. So how will you do this?
We need the
We find the
concentration.
concentration. We have the
Okay.
mass and volume.
Yes. Okay. So how do you find a concentration?
Mass over volume.
Mass
in
over
liter.
volume.
No dear, no dear. You
Uh,
have to calculate the molarity. Molarity is N solute over volume of the solution in liter. N solute means mass over molar mass. Mass is 0.1. So you have to find a molar mass of BaOH twice. Okay, Ba atomic mass is approximately 137.3. Then oxygen, it is 16 into 2, 32, plus 2 is 34. So the answer will be 171.6. Correct, no? Yeah. 171.3 times. What's the volume? 100 ml means 0.1 liter. Did you understand? Did you understand what I did?
Yes,
yes,
doctor.
doctor.
Yes.
N absolute is mass over molar. Oh, Rashid also came today. Last class you also were absent. Okay, now. Yes. Today Arva is absent. Hmm? Okay, tell me the answer. Okay, you will get some answer. Okay. What's the What's the answer?
It's 5.84 into 10 to the power negative 3.
5.84. After that, what's the next number? When you find a molarity, take all the digits. Don't apply significant figure in the first row, first step. 5.84.
So it's 5.837.
Okay. Yeah, don't round in the first step. Okay. Rounding can be done in the last step or something if you want.
5.8377
into 10 to the power minus
3.
molar. Okay, so now what's the next step? BaOH twice will give you aqueous gives Ba2 plus 2OH minus. So this is 5.837 10 to the power minus 3. So when you do the calculation, this number will be still in your calculator, no? So you can just do the next step and do the other one. So you will not lose marks. You don't have to do it again. After doing this thing, no, just multiply by 2, find out the pH straight away. Okay. So now you can calculate the answer and find out the pH. So pH is equal to minus log of concentration of 2 times 5.8 minus 3. Tell me the answer.
1.932.
Okay. So pH is equal to 14 minus 1.932. Okay. Did you understand? I hope everyone is okay, right? Direct simple question. If you know the previous lesson, this lesson is so nice. Okay. This one I don't know how to solve it. You should help me.
2 grams, so we divide 2 grams by the molar mass, by the moles, and then divide moles by the volume in liter. Just a second.
Hello, dears. I don't know this. This is from an old exam paper. I asked this question in one of the exams. Okay, you tell me. I don't know.
Doctor?
Yeah. Tell me.
I think that we should use M1V1 equal to M2V2. And we have M1 equals to 200 liter. I mean 0.2 liter. And M1 is 0.1.
Okay, so look, we have, suppose in a vessel, 200 millio, 0.1 molar SROH twice. To this, I'm adding 2 gram NaOH. Okay, now, first of all, you can find the number of moles of SROH twice. How do we find? You know the formula for molarity. Molarity is N/V in liter. Okay, so N will be equal to molarity times volume in liter. Correct? So it's 0.1 multiplied by 0.2. You know why 0.2? 0.02 mole. Sah? Sah?
Yes, doctor.
Okay. Now, SrOH twice is a strong base. It ionizes completely, and you get Sr2 plus and 2OH minus. Sah? Sah?
Yeah.
Okay.
Yes,
Yes.
doctor.
You have 0.02 mole. This is 0.02 mole. This will be 2 times 0.02 mole, that is 0.04 mole. So initially we had 0.04 mole of OH minus, correct?
Yes, doctor.
That you added 2 grams of NaOH. So I can find the number of moles of NaOH, correct? How will I find the number of moles of NaOH?
Mass over molar mass.
Yes, mass over molar mass. 2 over NaOH approximately 23 plus 16 plus 1 is equal to 40 gram per mole. So 2 over 40. What's the value of 2 over 40?
0.05.
Now NaOH is a strong base. It gives Na plus and OH minus, correct? So here we have 0.05 mole. Here you have 0.05 mole. You have 0. Mole. Did you understand? Understand? Did you understand?
No,
Yes.
doctor.
Yes.
Which one you didn't understand, dear? How to find the number of moles?
Yes.
So one number you didn't understand mass over molar mass.
No, I understand.
Then, okay. After finishing this, I'll explain again. Don't worry. Okay. So that means initially we had 0.04 mole of OH minus, that is from SrOH twice. Correct? Correct?
Yes.
Yes, doctor.
Now we have 0.05 mole of OH minus. Correct?
Yes.
So I asked you to find pH. So pH and pH depends only on the OH minus. We don't care SR2 plus or NaOH or something. Okay? Okay?
Okay.
Yes.
So now, in total, number of moles of OH minus total. Initially, from SrOH twice, we had 0.04. Now, from NaOH, we have
0.05.
0.05. So total, how much we have? 0.09 mole, correct?
Correct.
Okay, so now you know the volume. Volume of the solution is how much? 200 ml, correct?
200. Yes.
That is 0.2 liter. So I know the number of moles of OH minus. I know the volume of OH minus. I can find something. Come on.
Doctor,
Yes, my dear.
in the question, they say that 2 gram is added to 200 milli, so the volume will increase, right?
My dear. So actually, there will be a small increase in the volume, not too much increase in the volume. When compared to this 200 ml, when you add 0.2 gram of NaOH, the increase in the volume will be neglected. Because the increase is solid, it will go into the empty space within the liquid. So the increase in volume is negligibly small. So we take the volume of solution as just 200. Okay, you just imagine you have 200 ml of coffee, black coffee. To that you are adding a little bit of sugar and mix it. So the volume of your coffee will increase too much.
So we can solve it in another way, right?
Wait, dear. I will give you a chance to do the thing. Okay. Okay. Let me finish it and then I will give you a chance. Don't worry.
Yes.
So I can find the molarity of OH minus. So what's the molarity of OH minus? N number of moles of OH minus over volume of the solution in liter. So what's the number of moles total? 0.09. What's the volume of the solution? 0.2. So what's the value? Come on, tell me.
0.45.
0.45. Correct? Correct?
Yes.
Okay. Now, come on, tell me. You can find, come on, pH. So what is pH? Minus log of Turkish of OH minus. That is equal to minus log of 0.45. Tell me the answer for this.
0.346.
0.346. So how do I find pH? pH is equal to 14 minus pH. That's equal to 14 minus 0.346 is equal to 13 point, come on, 654. Okay, so yes, my dear, tell me if you have another method. You can just, of course, there are different methods. Yes, tell dear.
As we consider that the 0.2 liters for the solution, we can find the molarity of an AOH and solve like the previous methods.
Okay, so you just tell me molarity of NaOH you will find. Okay, and after that, what will you do?
I will find the concentration of OH.
Concentration of OH minus you will find, but then what about how? Tell me how you will find, then I can tell.
First of all, I find the concentration of an AOH.
Okay, concentration of NaOH in the solution you mean?
Yes.
Okay, fine. Yeah.
0.05 over 0.2 liter.
Then?
We consider that 0.2 is for all solution. And then I have
0.2, I mean 0.2, you mean molarity. You have to divide by molar mass. Right? You said you have to find the molarity, my dear, first of all. Molarity means you need number of moles.
Yes.
So number of moles will be 0.05.
Yeah, over 0.2.
2 over 40.
0.05 over 0.2. It will be 0.25.
Okay, fine. 0.25 is the molarity of NaOH. Okay, fine.
Then I have the SrOH2.
Okay.
It will has a molarity of 0.1 over multiplied by 2.
Molarity is given. Okay, 0.2. So it will be 0.2. Yes. So initially, how much? What is the molarity? Tell me.
It will be 0.45 also.
NaOH 0.5. How much you said?
0.45 total.
0.45 total molarity.
Yes.
Okay, and then?
Then the same thing as we did.
So I did same thing. Yeah.
Yeah.
The same thing I did. I just found the number of moles. Yeah. Okay. Yeah. Both of them are the same. As long as the volume is not there, since you are adding the solid, it does not make any difference, my dear.
Yes, doctor.
Okay. Yeah. So that's it. Okay, very good. You can do it in your own way. It's whatever is comfortable for you, you can do it. It's okay, no problem. Okay, it's good. Doing something in a different way also. Okay. Okay, this is something very important. Maybe you know this one because you did all this in the lab. Who is your lab doctor? Who was your lab doctor?
Mahwash.
Okay, she explained all this clearly, no? Spectator ions and all that, right? In the lab?
Yes.
Okay, maybe you forgot or not. Okay, anyway, listen. The first column, strong acids, second column, third column, strong bases. I told you last lecture, for strong bases, you don't have to memorize anything. Carmel from group 1 and group 2, only those three, calcium, strontium, barium. Can you see what I'm telling? It's written clearly, group 1, group 2. Okay, did you see?
Yes.
These all from group 1, these many from group 2. So these many are strong bases. We consider all other bases are as weak. So according to your level, that's the one. Okay. So these are the common strong bases. We consider other bases are as weak. Similarly, these are the strong acids. We consider other acids as weak. Now listen. Next thing, this is very important, spectator anions. Spectator anions means if you put these anions in water, Murphy reaction with water, these ions, they do not react with water. I hope you understood. So this is the meaning of the term spectator anions. Spectator cations and spectator anions, they do not react with water. Okay, they will remain as such. Okay, there is no chemical reaction between spectator ions and waters. Okay, so you need to know all the spectator ions. You don't have to by heart all those things. You know all the strong acids. So anion of those, Cl minus, from here Br minus, I minus, NO3 minus, SO4 minus, ClO4 minus from strong acids. And strong bases, see Na plus K plus all from group 1 and the remaining things from group 2. These all are spectator. So what do you mean by spectator? What's the meaning of spectator?
It doesn't hydrolyze.
Yes, they do not undergo hydrolysis. Okay, they don't hydrolyze in water. Okay, yeah. Now, next is for weak acids. Weak acids are of two types. Okay, you know all strong acids, all acids are considered as weak. Sorry. First type of weak acid is molecules containing ionizable hydrogen atoms. That means, look here, they are HNO2, HF, H2CO3, HCN. These all are acids which are not strong. Now the other one is cations, okay, not spectator cations. Sorry, let me correct it. Just a minute. Did you see what is written there? Can you? Oh. Yeah, dear students, did you see cations? What are cations? Cations means positively charged ions. Positively charged ions, except the spectator cation. Except means mada, correct?
Yes.
Okay, are acidic. I will explain it. I'm going to explain this part again. Don't worry about it. How these cations behave like acids. Okay, this part is going to be explained. I hope you understood. So we have two types of weak acids. One type of weak acid, just they are molecules containing H plus, and other one means cations. Cations means positively charged ions. Positive Okay, except spectator. Okay, spectator neither acidic nor basic. Okay, now here a general equation HB giving H plus plus B minus. Do you know why I put this reversible arrow?
It's a weak acid.
Yes, it's a weak acid. Or instead of writing like this, we can write this. This is actually more correct way. But usually we write this way because it's so simple. HB. HB is an acid. It gives H plus to H2O. So you will get H3O plus and B minus. So now Ka is equal to concentration of the products by concentration of the reactant. So either you can write Ka as concentration of H plus times concentration of B minus over concentration of HB, or this one, concentration of H3O plus times concentration of B minus over concentration of HB. So this K is the ionization constant for weak acid. Is it okay? Ka is the equilibrium constant or ionization constant for a weak acid. Then now, pKa, you know, like pH, pKa is equal to minus log of Ka. And another very important thing, if Ka value is high, what do you mean by Ka value high? Tarkis of the product will be high. So that means it gives more H plus. If it gives more H plus means strong acid or weak? Strong acid. So that means for a strong acid, Ka is high. If Ka is high, because of the negative sign, pKa will be
low.
pKa will be low. Okay, so for a strong acid, Ka is high or pKa is low. Okay, did you understand? Did you understand?
Yes.
Okay, okay, so now here we have similar, here this is a general equation HB. So we can write, so how do you write the equation? Say for example HCN, I'll write the equation for HCN. So how do I write? Tell me. HCN, come on, aqueous can give, tell me, H plus aqueous, Cn minus aqueous. There is a mistake. What is the mistake? What's the mistake in this equation which I wrote?
Double-sided arrow.
Yes, that is very important. Okay, one side arrow is wrong. So I will use a different color to illustrate it. So Ka will be equal to concentration of H plus or molarity of H plus time concentration of C minus over concentration of HCN. Whereas if it is a strong acid, how do you write? There is no Ka. We just write just one side arrow. Okay, understood?
Yes.
Did you understand? So now I will show you how the cations are acidic. Okay. Oh, so many things. Okay, so I'll write this one of the equations here itself just to show you this. My dear students, look here. NH4 plus. Okay, you can do it in two different ways. Plus H2O. It gives. Come on. It gives. Oh. It gives H plus to H2O. So H2O will become H3O plus. Plus the other one is NH3. You understand what I meant? NH4 plus is giving H plus to H2O. So this H2O will become H3O. H3O. Come on. Come on. H3O plus. You didn't understand? I'll just do it in a simpler way. Or it can be written like this. NH4 plus aqueous, okay, will give NH3 plus H plus. Since it gives H plus, it is acidic or basic?
Acidic.
Acidic. Giving H plus means it's acid. So you go for K or KB?
Maybe.
Concentration of NH times concentration of H over concentration of NH4 plus. Okay, done? Okay, understood?
Yes.
Understand? Okay, so now what's the other one? AlH2O6 times 3 plus. How does it work? AlH2O 6 times 3 plus. Okay, how to explain dust linkage? We can do it in two different ways. Okay, one long way and one short way. Just give me 1 minute, I will finish it off. Okay, so how many minutes we have? Okay, 10:40. Okay, I will explain this one next class so that I can explain more questions. Even if I explain one time, I need to explain it again next lecture. Okay, so we'll do it next lecture. Please revise and come. Do you know when your next quiz will be?
At 10:05.
Yeah, on 10th. Okay. Time remains the same. Only thing is the day is different. Okay.
Is it at 10 o'clock? Or
What did I give before? It was 9 o'clock. What was the timing? 9 to? I don't know the time which I gave before. The same time. Last time I changed the timing because there was a clash. I will let you know about the time. Don't worry about the time. It's okay. I'll just don't